Hey everybody, today we're going to be talking about quadratic graph characteristics. So a quadratic is an equation where the biggest exponent is an x squared. And the standard form of that equation looks like y equals ax squared plus bx plus c. So the biggest exponent is that 2. And when you graph this creates a U-shaped graph called a parabola, which we've seen a lot when we've been doing domain and range this unit. So parabolas look something like this. So parabolas can either open up or open down. So graphically, you can kind of see it, but in an equation, that a in the front of the equation, if it is positive, it opens up. So opening up looks like this. And then if it's negative, it opens down. So it's facing downwards. Something else about parabolas is they are symmetrical, and they are symmetrical like there's a vertical line that divides the parabola into 2 equal parts. And that invisible line is called the axis of symmetry. So when you have a parabola, so we've got that U shape, there's an invisible line that cuts through the center. That's the axis of symmetry. And the equation for this is written as x equals whatever the x value is that it's cutting through, because an x equals equation is that vertical line. If you didn't have a graph and you just had the equation, you could also calculate the axis of symmetry using the equation x equals negative b over 2a. And that would let you calculate the axis of symmetry. Parabolas, because they're a U, they only have one turning point. So one spot where it either switches from increasing to decreasing or decreasing to increasing. So we'll either have a maximum, so the lowest point, or a minimum, which is the high. Wait, that doesn't even make sense. Nope, that's totally backwards. So a maximum, that's the highest point. And the minimum is the lowest point. Typo. And the ordered pair is called the vertex. So we'll get to that when we look at the graph. And then solutions, the solutions to a quadratic equation are the points at which the function intersects the x-axis. And we're going to be looking at solutions a lot this unit, and solutions have a lot of different names. So if that's where it's crossing the x-axis, those are the x-intercepts. But math likes to give things a lot of words, so x-intercepts are also called roots, or they're called zeros. So a lot of different names, solutions, x-intercepts, roots, zeros, and they all mean the same thing. So now let's look at this on a graph. So looking at this parabola, see its opening is facing up. So up here is up, down here would be down. So if the opening is facing up, we say opens up. And because it opens up, this point where it switches from decreasing to increasing is going to be a minimum because it is the lowest point on the graph. So I'm going to circle minimum, and that minimum point is at 1, 2, 3, 1, 2, 3, 4, 5. So -3, -5 is where that minimum is happening. That's also the vertex. So it's the minimum and it's the vertex. So a vertex is where it switches direction. So the vertex is at -3, -5. The axis of symmetry always cuts straight through that vertex. So this invisible line of symmetry is the axis of symmetry, and it's cutting through where x is a -3. So notice the -3 in the vertex should match the -3 in the axis of symmetry. That number will always be the same. Domain of all parabolas, it's going left forever and right forever. So its domain is -infinity to +infinity. And then the range is how far down it goes. So the lowest this is going is -5, and it's a solid line, so it gets a bracket, and then it's going up forever. And then our solutions, those are the x-intercepts, so it is hitting right here and right here, so it has 2 solutions. And remember, solutions are the roots, so those solutions are at the point 0, 0, and at the point 1, 2, 3, 4, 5, 6, so -6, 0. All right, let's look at another one. So flip the page. So this one, we are opening down this time. So the opening part is facing down, which means the vertex point, it's switching from increasing to decreasing. So this is going to be a max. And that max is at the point 4, 0. The vertex is also at that max. So your vertex is also the point 4, 0. My axis of symmetry is the invisible line that cuts through that. So my axis of symmetry is happening at x equals 4. Domain, it's always opening left and right forever. So really, if you want to write yourself a note, that's going to be the same for all parabolas. So every time you have a parabola, it's going to be negative infinity to positive infinity, as long as you've got those arrows at the end. Range, the lowest it's going is negative infinity, and then it's stopping at the y value of 0. This one only touches the x-axis once, so it has one solution, and that solution is at 4, 0. So the next two, they didn't give us a graph. So let's see how much of this we can figure out without a graph at all. So first thing is asking how it opens. So remember the A, so what's in front tells me how it opens. So because that's a negative, that means it opens down. So right away, I know it's going to open down. And if the graph opens down, I know the point at the top is going to have to be a maximum. But where is that maximum? So we found out the formula. X equals negative b over 2a tells me the x value where your vertex is happening. So in this formula, our a is negative 3, the c is 3 because it doesn't have an x, and the b is missing, so the b is 0. So if I plugged this in, it would look like negative 0 over 2 times negative 3, which equals 0. So I know the axis of symmetry is at 0, and that number always matched the x value for the vertex and the max. If we wanted to find the y, hopefully you know that you could plug this 0 in for the x in the equation to find the y. So we'd have y equals negative 3 times 0 squared plus 3. So that'd be 0 plus 3, so y equals 3. So the y value in the vertex, which is the maximum, is 0, 3. So I know on the graph that my point is happening at 0, 3. So if I just give myself a little rough sketch, 0, 3 is here, and I've got a parabola facing down. So I know for the domain, every parabola is negative infinity to positive infinity. And then my range, this is going down forever, and then it stopped at 3. Based on where its maximum is and it's facing down, we can see that it's going to have two solutions, so two x-intercepts. But this is where we kind of get stuck. So later this unit, we'll figure out how to find the x-intercepts, but right now we don't know how. So we are going to use a graph to do this. So get out a graphing calculator, and I'm going to pull one up here. So on the graphing calculator, you're going to hit y equals, and then our equation is negative 3x squared plus 3. So once you have that typed in, hit graph. Boom. Okay, that looks just like our drawing, which is awesome. So hopefully you can kind of see it's hitting the maximums at 3, so that's at the point 0, 3. And really you can see your x-intercepts, so they're happening at negative 1 and at 1. But if you couldn't see that very well, what you could do is hit second, trace, and then 0 is another name for x-intercepts. So if you hit enter, when it says left bound, you want to go to the left of that x-intercept. So I'm focusing on the left x-intercept first, and I hit enter. Then I go to that right of that x-intercept, hit enter. So basically my x-intercept is centered between those two. And then it says guess, and we're like, yep, so hit enter one more time. So that 0 is at negative 1. So we could do it again. So if I hit second trace, then we'll go to 0 again. Now I'm going to go to the left of this x-intercept, hit enter, then go to the right of it, and then it says guess, and we say yep, so hit enter again. So that one is hitting at 1. So going back to our page, we know our x-intercepts are at negative 1, 0, and 1, 0. So because you have your graphing calculator, all of this math we did over here, you don't have to do because we need it for the x-intercepts, but later we might need to do it. So let's see it one more time. So again, this time in front it's positive. So if it's positive, we know it opens up. So it opens up, and if a parabola opens up, we know that the point at the bottom is going to be a minimum. So now we just have to figure out where that is. Ooh, right away we actually know domain. So domain is always negative infinity to positive infinity. All right, let's check it out. So x equals negative b over 2a. So my A this time is 1, my B is the -2, and the C is -15. So x equals -2 over 2a. So negative negative is a positive over a positive, so x equals 1. So I know my axis of symmetry is x equals 1. My vertex is an x is 1, and so is my minimum. Then I've got to plug that in for the x's in the equation. So that'll look like y equals 1 squared minus 2 times 1 minus 15. So 1 minus 2 minus 15, -1 minus 15, so -16 is our y value. So on a graph, what our parabola would look like is that 1, -16 is going to be our vertex, and then it says opens up, so I know it opens like this. So right away you can see that it's going to have two solutions. In the range, the lowest it went was -16, and the highest it went was infinity. Again, we don't know how to find the solutions yet, but we will. So we can use our graphing calculator to find the x-intercepts. So I'm going to clear this, go back to y equals, and clear the equation. And this time we have x squared minus 2x minus 15. And we'll graph it. So if you can't see the graph fully, you always could zoom out or extend your axes. However, we only care about the x-intercepts because we found everything else. So we're going to go to second trace, and we want the zeros. So the left bound, I'm just going to move my cursor until I see it. So I'm going to the left of that 0, hitting enter. Then I'm going to the right of that x-intercept, hitting enter, and then we're guessing. So that one happens at -3, 0. Then we're going to do second trace again, go to 0. Now I've got to get to the left of the other one. Oh my goodness. Okay, there we go. Hit enter, go to the right of it, hit enter one more time. So our x-intercepts are at -3 and at 5. So because I know sometimes we forget things and maybe we don't remember this -b over 2a, it is nice to know on the calculator how to find that maximum or minimum. So let's look at that. So I'm going to fix the window really quick. So our y-axis isn't going down far enough. So if I go to window and then I change my y minimum to be like -20 so that we can actually see the whole graph. So I just extended my lower part of the y-axis. So if I want to find the minimum there, I'm going to go to second trace, and then I know it's a minimum. So I'm going to go to minimum, and then we're doing the left bound, right bound again. So I'm going to the left of the minimum, hitting enter. Then it says right bound, so I'm going to the right of the minimum and hitting enter. And then you say guess, yep, so you hit enter one more time. So the calculator gets very, very specific, but 0.9999 is going to round to 1. So our minimum is at 1, -16, which is what we got. And that matches our 1, -16. So that should be everything you need for graphing and the characteristics of quadratics. Good luck.